iPass Interconnect System. Welcome to this module on the iPass Interconnect System from Molex. This module will provide an overview of the iPass interconnector system, its mechanical and electrical advantages, and its applications. The storage industry is undergoing a transition, with high-speed serial devices beginning to replace older parallel buses that have difficulty scaling to today's as well as tomorrow's high-speed systems. As part of this transition, more pins are freed up for more bandwidth, which yields more potential lines of data, higher density silicon drives, and the opportunity to increase port density, and in turn, the higher density I/O can help drive both the optimization of current mechanical form factors as well as drive entirely new form factors. iPass is inherently a cable-to-board system intended for high-speed and high-density applications. There are options for both internal, meaning inside of the box, as well as external applications, meaning I/O. The basics of the iPass system include a 0.8 mm pitch, a surface mount card edge host connector that is used for both the internal and external applications. iPass products include unique internal and external guide frames, which will locate and provide latch points for the mating cable plugs, and third, uniquely appropriate shielded cable assemblies are offered for both internal and external applications. The mechanical advantages of iPass encapsulate the proven technology and ensure capability of the supply during high-volume implementation. It's less complex, so it reduces the overall costs, and the system-level benefits through increased density and cleaner cable management are some of the things that are going to be at the system level with regards to the advantages that the system offers. The iPass products support many SAS SATA industry standards for high-speed, multi-lane internal and external systems. First, it is electrically capable of supporting both Gen 1 and Gen 2 data rates, as well as beyond. Secondly, the same connector can be leveraged for both internal and external applications. And third, the physical sizes of the current standard connectors, also noted in this matrix, were not scalable to the densities required by the market. Following the mini SAS SATA standards, the second industry standard to adopt iPass was PCI Express. Now, PCIe is the next-generation multipurpose I/O interface that can be used across the computing industry, from mobile to high-end servers, as well as communications, networking, and other equipment. iPass provided the flexibility and future scalability by supporting Gen 1 and Gen 2 PCIe protocols, as well as beyond. Now, PCI sends data through differential signal pairs called lanes, and multiple PCI lanes can be grouped together with typical lane widths of 1, 4, 8, or 16 cable copper links. However, unlike PCI, which shares bandwidth with all devices on the bus, each PCI Express device receives dedicated bandwidth, and the iPass was chosen to support all the lane widths that were defined by PCI, specifically the X1, X4, X8, and X16 configurations. The iPass connector is derived from a high-volume 0.8 mm pitch card edge connector family that has been used across the industry, including SFP, XFP, and XPAK. The low row of contacts was redesigned to match the data rate capability of the upper row. But iPass also offers manufacturing advantages over other high-speed I/O in that it's a surface mount connector, which is assembled during standard component placement using tape and reel packaging. Additionally, unlike other I/Os, it has no balance or center of gravity issues, which will also in turn benefit the manufacturing process. This graphic shows a comparison of the iPass cable plug technology, which is the graphic on the left, versus a legacy I/O on the right. One of the first things that iPass removed was the stamped and formed contact with an overmolded connector that is used on the legacy I/O product, and the iPass solution showed that it's just a straight-through paddle card edge connector system. iPass increases I/O density in standard mechanical architectures. As the various segments of the storage and high-end computing markets drive for the increased port density per card, iPass is becoming the standard interface due to its original design for compatibility to these standard mechanical architectures. This example of the increased I/O density is using a PCI card. The graphic shows a simple comparison of the original SAS Interconnect System compared to the new iPass system. From the storage and computing markets to the telecommunications industry, iPass supports the ATCA card applications and provides all of those same benefits that are inherent in the design. The graphic actually shows 8 AMC mezzanine cards that have iPass implementation. So certainly the message here is for the ATCA marketplace where, again, higher density is needed, higher bandwidth and speed is needed. The iPass cabling and connector system is a perfect solution to address both of those needs. Another mechanical advantage that the iPass system brings to the data center is related to the bulk cable-intensive routing issues that face system designers and installers. The iPass cable plug has a much lower profile extending from the front of the chassis or faceplate, which allows the cables to be dressed and routed to the cable troughs, which are typically on the right and left in a shorter distance overall, resulting in a much cleaner environment for the cables to be routed up, down, or left or right. iPass offers some significant signal integrity capabilities to the users of this market. It was designed for that application and derived from the 0.8 mm progression connectors used in SFP, XFP, and XPAK, and, from the outset, was improved to the point of integrating the features, including a direct attached paddle card interface. SMT leads on the host connector improves the transition on the host side, as well as on the target device side electrically, allowing for different implementations of stack and routing than are sometimes present when you're dealing with the pin field connector. In addition to these capabilities, a full model set of SPICE and S-parameter models is available for the iPass connector family. The reduced number of components, the reduced number of signal transitions, and the mating interface to the connector back into the cable improves the speed as well as providing for greater space on the PC board in some applications for active components or equalization. In doing so, it provides in addition to the signal integrity performance. Here are comparative charts. On the left, we see the multiple driven pair next to as measured for the InfiniBand single data rate specification. So head-to-head against our LaneLink SSF8470 product, you can see the improved isolation pair-to-pair, which is present in the iPass system as compared against that legacy I/O. 3 inherent levels of EMI control are present within the system. The ground connections are on the base of the housings of the whole circuit board on the host connector, a gasket present between the housing and the system faceplate on the inside of the bezel. On the outside of the bezel, a gasket is partly between the cable plug and the faceplate, and there are multiple ground connections in the cable plug through the housing of the PCB through those interconnects. And the standard product includes an EMI guide frame, which not only enhances the mechanical performance of the system, but also optimizes the EMI performance without secondary application of components.